All right, Precalc, we're going to continue to solve some of these problems right here. Let's go ahead and look at this one right here, example 4. Example 4 says solve this 6 times 2 to the t plus 5 plus 4 equals 11. We have to perform our algebra 1 first. The first thing we're going to do is get rid of. So we have 6 times 2 to the t plus 5 is equal to 7. Then we're going to divide by 6. 2 to the t plus 5 is equal to 7 over 6. I have to rearrange this into a logarithm because I could never solve t plus 5 in the exponent. So I'm going to rewrite this as log base 2 of 7 over 6 equals t plus 5. So log base 2 of 7 over 6 ends up being 0.22239, and I know that that's equal to t plus 5. So all I'm going to do is subtract 5 from each side, and t is equal to negative 4.7776. So it's just like algebra 1, but when you get to the logarithm part, we have to put it in a logarithm. All right, moving on to the next one. The next one students struggle with because it looks hard, but if I tell you how to do it, it will be a little more simple, obviously. So let's go ahead and let's let e, so we're going to let a equal e to the x power. So notice this would be a squared minus 7a plus 12. Well, I know the factors of 12 that add up to be negative 7 would be a minus 4 and a minus 3. So I know a would equal 4 here, and a would also equal 3 when I solve. But remember that a did not equal a was equal to e to the x. E to the x. And anytime I see an e, I need a ln. So this becomes 1. X flies to the front. So x is equal to the ln of 4. And, again, flies to the front. X is equal to the ln of 3. All right, so the ln of 4 is approximately 1.386, depending on how the question asks you. The ln of 3 is approximately 1.099. All right, moving on to B. B is telling us log base 4 of 3x plus 2 is equal to log base 4 of 6 minus x. Almost looks really confusing, but remember that if these are equal, they could just be canceled out. So really all this is saying is good old algebra 1, 3x plus 2 is equal to 6 minus x. Add the x over. 4x plus 2 is equal to 6. Subtract the 2. 4x is equal to 4. So it looks like x equals 1. Now, the next one is definitely a little bit tougher. C says log base 3 of 5x plus 13 minus log base 3 of 6 is equal to log base 3 of x. Well, I know, all right, this one's a little bit more difficult. Remember, because of the subtraction, I know this is going to be log base 3 of 5x plus 13 over 6, and that's equal to log base 3 of 3x. When I have a log base 3 and a log base 3, those can cancel out. So again, we're back to algebra 1. 5x plus 13 over 6 is equal to 3x. And I'm just going to put this over 1. Remember, we can cross multiply. Keep the top left on the top left. Keep the top right on the top right. I'm going to write over here. So we end up with 5x plus 13, and 6 times 3 is 18x. When I subtract 5x over, I get 13x, and x is equal to 1. Moving on, They're asking us to solve this one. And the first thing I want to do, well, I'm going to rewrite it first of all. I want to get rid of this 6. Don't want to divide, we want to subtract 6. So we have 3 times the natural logarithm of x is equal to -2. When I divide each side by 3, I get the natural logarithm of x is equal to -2/3. Remember that log base e is my natural logarithm. So I'm going to rewrite this as log base e of x equals -2/3. And when I put this back in exponential form, e to the -2/3 is equal to x. Well, they are asking us to put it to decimal form. So I'm going to take my TI, I'm going to put e to the -2/3. And that is equal to 0.513417. So if I have to round 3 places, I'm going to round it to 0.513. And let's just look at one more to solve. 3 times log base 4 of 6x equals 9. The first thing I'm going to do is divide by 3. And I get log base 4 of 6x is equal to 3. And remember, I want to put this in exponential form, so I'm going to write it on the top. 4 to the 3rd power is equal to 6x. 4 to the 3rd power is 64 equals 6x. When I divide each side by 6, I get 10 2/3. Great job.